John Muir and Jack Hicks, who's in charge of our project team, along with Bob Gordon, our project manager.
Or inside there.
One of the people you may see on a BRS job at a future project. Careful, don't get your hands dirty.
I'm trying not to. We're not allowed over there. We don't have our herd hats on.
I see. Drain connections being fully installed and more trench work in the area, common area, just for drain purposes. And obviously this has to be coordinated through all the sleeve penetrations in the front end of the project. This project being done very much as a fast track design build orientation, so knock on wood or metal I-beams, we haven't had a lot of problems whatsoever in coordination of the project so far, and it's a contribution to the staff that we have working on it. Masonry from the last pictures that I took, obviously it's coming along very, very well. One heck of a lot of block. I'm not really sure. Probably about 3 weeks ago. But that was just all the foundations. They didn't really start putting block up in the air until about a week and a half ago, I think. Thanks for building the rink. That was probably one of the boringest videos we've ever watched. Try to build the transmission lines in the longest length possible, which can still be handled with, because of shipping purposes, it's about 40 feet long. And then the lowered equipment on site to lower it down into the trench. Right now they're bringing it all into position. Approximately they'll insulate it, put the vapor jacket on, and then they'll lower it into position. They'll have wooden cribbing that you're going to see in future videos that position all the transmission lines. Typically all this work is the work of the general contractor. It's coordinated with our project management staff, and this trench will be ready by the day we come to put the transmission lines in. I came up here to visit with the masons a little bit, and hopefully I won't get in their way so they won't bury me into any concrete. We're seeing here that at every column line they have an expansion joint, so the building can move independent of the walls, and the walls can move independent of the columns. And this is at every position of column. You'll see a line like this at every column location. These are the reinforcing steels that I indicated earlier. That's needed for structural integrity of the wall itself, the combination of the height, and then there'll be a layer of hollow core that goes on top of that.
Half the wall and then we get to the top.
Oh really? So far you're about halfway done with this wall at this point?
Yeah, from right here.
Okay, that's the halfway point. Alright. And then when you get up, what do? You tie another rebar to this and continue it up to the whole way to the top?
Put it down past it, and that ties it when you pour it.
Okay, I understand. Now what are you guys pouring this with? Anything special? Just regular grout?
Yeah, go.
Okay. And then these reinforcing steels that you're doing here, these cross members. These pieces, the wall ties, how often do you put them in?
Every 2 courses.
Every 2 courses they go up. And you've got so many courses that you guys can do a day before the wall will slag or something of that nature? Okay. You guys are doing a nice job. The strike work and everything looks really, really good. That's a calibrated hand, I can tell.
Oh, yeah.
If you do it enough times, huh?
Yep.
So here we're going to add another column line, and they've got an expansion joint. They just got it bent over itself right now to keep that out of everybody's way, but that'll continue right up the wall as they go up the beam. How many blocks are going in this building? You guys have any idea?
No.
No idea? A lot of them, huh?
I'll just walk right in here and get us.
Okay, where's Bob Vila at here? We need Bob Vila here.
Probably want to use Friday. You're going to have to pressure test it. Yeah. Walk in, pressure test kits off.
Perimeter getting prepared. You can see the vapor barrier has been placed around the entire perimeter at this point before the concrete is poured. Compacted. Everything's shot with the laser levels, very, very critical. The fishing lines insulated, getting ready to be put down into the trench work. Masonry work progressing very nicely. Pipe will be sitting right on top of all this wood cribbing that's been put into the trench. The way it can be properly backfilled around and it won't damage the insulation. These are pressure treated 4x4s which will just be buried right into the soil for the backfilling process. What's your schedule today?
I want all this pipe in here today. That's what I want.
There you go.
Cut well tomorrow.
Good.
Are you videotaping me there?
I'm videotaping you right now. When you guys planning on pouring this?
No idea. We don't pour it.
Get the grade ready, huh?
That's not next week, I think.
How things going over here? How you guys making out?
Good. Pretty good.
Everything going together okay?
Yep.
How you doing?
You need a hard hat, sir.
I know I do. shows all the conduit run around. This is actually for a smoke system that we'll be using for special effects in Public's meeting. All the reinforcing mesh and rebar is in place on the perimeter. Elevation is a very, very important factor around the perimeter. The ice will seek its own level. That's what he's shooting, pads, and running the laser device. Drain connections, which are actually going to be located in each one of the players box areas, and the purpose for that is for easy maintenance and wash down in the players box areas. Here we have the conduit that's stubbed up for the timekeepers area. This includes a PA sound connection, 110 volt connection, and also connections for the scoreboard conduit locations, which will run to the scoreboard location and also to where the goal lights are located on each end of the rink. Transmission lines are fully installed and pressure tested, fully insulated for both the secondary fluid or the refrigeration pipes and the subsoil heating pipe. At this point, they're backfilling it with a highly compactable material, which is not deleterious to the safety of the pipe. There's no rocks. Basically, it's a sand or a rock dust type material. They're compacting it to a 98% by modified Proctor. Compacting a very, very important element in all preparation of the rink floor. This area will be fully concreted over, except for an access pit cover that's located right here where we connect with a flexible connector to the main header pipe. You can see the dock plank has been installed. Makes a very nice smooth structure. we're up on top of that newly placed dock planking. Get a good view of the overall site and what the elevation is going to be like for the second floor area. The masons are moving right along. They say there's about 45,000 blocks that are going into this total project for masonry. Some of the center dividing room, walls between the locker rooms. Here we're on top of that dock planking. The surface itself on the dock planking is very rough, and they're going to be putting in approximately a 2-inch skim coat over the top of this to create a smooth concrete floor on the second floor area before carpeting and things of that nature go down to the corporate offices. Workers are just putting up some safety rails around the perimeter for OSHA regulations. Over here in this section, we can see where on the second floor, the staircase is coming up. And the electricians are down there working, backfilling over their electrical lines. A little bit later on into the project, you can see floors in the mechanical room here have been poured. No melting pit. Shows the current state of the project. About half the roof's on, light fixtures have been put up. Most of the concrete perimeter is already in place. There's a good shot of the insulation system that's gone up. Quick picture of the lighting fixture, which is a 400-watt metal halide fixture. You can see by the way they ran the electrical conduit, all the conduits actually hid up inside the purlin. Strapping system that we're using for the insulation makes a real nice drop ceiling effect where the purlins are fully encapsulated by the insulation. The insulation is really running nice as opposed to a basket system or what they call a bag and bag system. After the fixtures are up, because they're still in construction, the electrical people bag the lighting fixtures to keep them cleared and protected, clean and protected. Here's the Zamboni area. We come out, you can see that there's been a trench drain put into the concrete perimeter. This is where the Zamboni gate will be located at. The concrete perimeter radius has been poured. You can see here some electrical conduit that's been stubbed up for specialty light and smoke and laser effects that are going to be created on the ice sheet. They've begun the process of starting to strip the area for the rough grade, which is a very important factor too. On a sand-based floor, it's typically 9.5 inches below finished floor elevation. On a concrete floor, it's approximately 12 inches below finished floor elevation. And they'll be going ahead and shoot that. It's better for the general contractor to shoot this area a little bit low as opposed to too high. The process will begin, as you'll see in further filming, where the subsoil heating system will go in first, and then they cover with sand. If the grade's a little bit low, we just have to bring a little bit more sand in under that kind of criteria. Important prerequisite, as mentioned earlier, is the elevation of this perimeter has to be dead level. Here we see the R19 internal wall insulation. being covered by an 8-foot high liner panel. And the purpose of this is to keep the hockey players and the kids from getting into the insulation and tearing the membrane in any fashion. And that'll just go right into the wall girders.
Alright, we're ready to move down.
That's it, just like Ford, quality, job one here, right? He did this just for the video, I want you to know. Some more shots where the liner panel's been put up back behind the area, not behind the boxes, but on the box side. As you'll see, over here, we don't have any liner panel on yet. And the reason for that is that'll actually be a plywood attachment with polyethylene covering. And that'll be the area that's right behind the players' boxes. The metal liner panel, if we put that behind the players' boxes, will get dented and require an awful lot of maintenance, where the plywood polyethylene composite won't require any maintenance whatsoever. And unlike block, it also won't need painted at any particular point in the future. You can see here where the draining stub-ups are. We have to go ahead and pour back a concrete elevator floor for the elevator players box area, which hasn't been done yet. That'll be done after we go ahead and put that backing on, so that backing can actually act as a form for the concrete. Over here you can see a little bit of a mistake that was made. There was a mistake on the drawings from a structural standpoint, and we lost one of the beams and some of the hollow core right in that location. That happened this morning. Fortunately, nobody was hurt, and that'll be corrected pretty quick in here. You can see the building going up. We're outside the mechanical room. See here we have the transformer set on its pad. Condenser pad where the evaporative condenser will be located at. Coming on through. Seeing the rest of the big blue building. And preparation for the dehumidifier pad for the ice rink area, which is shown right here. That hasn't yet been poured yet. The dehumidifier will require electric and a drain connection to operate properly. Here you see the stub-ups for the electrical. And the gas has not yet been run, but it'll be run over here as well. Here's some shots of the insulation that we're using in the rink area. I don't know if you can notice by this, but there's a series of fine perforation marks on this side. And this is the actual shiny side that faces down to the ice rink. And the thing that we do not want to create is a vapor barrier on the bottom side of the insulation. That'll create a condition where we'll have condensation within the insulation membrane, which will be detrimental to the insulating properties that it provides. These all come in rolls. The material that we're holding here is a product called Arena Shield. On the back side, I don't know if you can notice real closely, it's a nylon reinforced material. There we go. It's super strong. The hockey puck can't go through it at all. And then this perforation is done before it's actually laminated to the fiberglass. This is provided by a company called Thermal out of Ohio. It's a very good quality product, and we found the best value for this application. The thermal material comes in rolls just like this, and there's actually 2 layers of insulation up on the roof structure. One goes with the purlins, the other one will go across the purlin the other direction with a true vapor barrier, not a perforated vapor barrier, but a true vapor barrier that lays on the top against the outside metal deck of the roof structure. Here we are on the second floor roof structure. We continue to put masonry up around the stairway exit to the second floor. You can see up ahead here, once the roof's on, there's an opportunity to see a good close-up of how this insulation package works, which is really sweet. See, that strapping mechanism that we put in is a perfect basket for the insulation. If you look close there, now you can see the perforation in the insulation. The reason for that is even though there's a vapor barrier on the top side of the insulation, it's impossible to get a true vapor barrier. At some point there'll be some failures. A pinhole, for example, can affect a 10-foot radius area. And if that should occur, instead of hitting heat point within the insulation membrane and ruining the insulating properties of the fiberglass, that humidity will breathe into this space and in itself become part of the dehumidified space, of which the dehumidifier will contain that humidity. The biggest concern, of course, is once we would have condensation within the insulation membrane, you'd never effectively be able to dry it out. And all it takes is 1% moisture in fiberglass insulation and you're going to lose 78% of its R value. Because the material is in itself the finished product you're looking at, great care has to be undertaken by the contractors not to have a situation like what I'm showing here now. This is a small area at the very beginning when they started putting insulation down where the roll was drug across the ground and it scraped some of the aluminized material off the skin. Now, of course, that will be repaired and not left in that condition. But it's a good example of little care goes a long way. The beams still here shown are red oxide, which, as mentioned earlier, should have been ordered gray instead of red because they'll cover easier. They'll be cleaned and everything will be masked very well before the beams are painted. Starting to look like an ice rink. Now we'll go up onto the roof, see if we can see what the insulation package looks like from up there. It's just about at the top of the ladder. I just wanted to take a shot showing how the insulation is very nicely held into this basket. It's just slightly puckered down below, which gives us a little bit of a pillow effect. But at the same token, it's pushed tight against the purlin so we don't have thermal shorts, similar to the insulation systems that are what they call a sag and bag situation. And you can see how the members connect to the main structural beams. See if we can focus in on who supplied this thing. There we go. Alien Industries. Hurry up on the structure. Now this is a standing seam roof. The reason it's called a standing seam roof is that indeed these are the standing seams. The metal is bent in such a configuration that the metal comes up, and then is bent over itself. So at an elevation, it's higher than the rest of the roof structure, and it's also sealed to prevent rain from going in. You can see right here where they have a temporary crimp on the standing seam roof where it's bent and then it appears to level back out. Well, that's a temporary crimp that they do while they're installing the roof structure. What they'll do afterwards then is they'll roll those entire seams with a rolling machine. So the whole standing seam will be crimped in this fashion. What this enables the workers to do is move fast, not worry about that, and actually use the best tool for the job to crimp. And if for some reason something was required the roof panel to be pulled off, at this point it still could be pulled off. The roof decks themselves come in a pallet which they lift up here with a crane. Here you can see
the roof panels itself, the material that's used for that. The screws that you see here are what they call a lap connection. There's a very minimum of these that are put in. These screws have a rubber grommet below them, and this is pretty similar to what they use with a screw-down roof as far as the screws and fasteners. The only thing is there's only a fraction of them with a standing seam roof that you'd have in a conventional screw-down roof. Those laps are approximately every 20 feet, and they seal them fully. Also, the standing seam is sealed with a silicone or some type of a mastic, depending on the manufacturer of the building system. So when that joint's actually folded over, it's also sealed. Lapping joints are very much like a shingle concept. Before the steel goes together, there's approximately an 8 to 10 inch overlap of the steel, and there's at least 2 layers of high strength mastic that's put down between the metal panels, so when they're screwed together they're also sealed. You also have, of course, the benefit of it being a sloped roof and the gravity of it. Some of the other benefits of the standing seam roof as opposed to a screw down roof is the sheer enormity of size of an ice rink roof, is that even with wind there's an awful lot of movement of the steel, which has a tendency to loosen those fasteners when you use a screw down roof and create roof leaks. Also, just because the thermal changes from a hot summer day when that roof panel is very warm, maybe 130, 140 degree temperature, to a very cold winter day where maybe 10 or 20 below zero, that steel will have a tendency to move a great deal, and that movement over a period of time with a screw down roof creates a lesser reliability as far as leakage. Here's showing the insulation package, which is actually rolled out before the steel goes down for the roof. This comes, as we saw earlier, with a roll, and there's a rolling system that they continue to just push this right out across the roof. The way this insulation was made, you can see underneath that the insulation doesn't come the whole way out to the far edges. It's actually recessed in by about 10 to 12 inches. The reason for that is these tabs are pushed up into the purlins. So the insulation fits tight to the purlins, but these tabs wrap up in and over the purlins and get held in place. And it makes a very nice, neat looking roof system. When they're not working, because of potential bad weather, which we've got some coming right now, it's quite windy, they only roll out the insulation in such a fashion that it's always protected from the rain. The roof is open for them to drop the hollow core down in with a crane.